In the outer depths of our solar system, more than 500 astronomical units from the Sun, far beyond Neptune, something massive is hiding in the darkness. Every planet, asteroid, and comet in our solar system orbits one central force, the Sun. But when astronomers look deeper, something didn't add up. Objects at the edge of our solar system are behaving strangely, as if something unseen is pulling on them. The leading explanation? A hidden world, a massive planet traveling on an enormous, elongated orbit far beyond anything we've ever observed. This mysterious object, known as Planet 9, could be 5 to 10 times more massive than Earth, and yet, despite decades of searching, we still haven't found it. Astronomers have been searching for evidence of this unseen planet for centuries. Today, scientists at organizations like NASA can observe galaxies millions of light years away, and yet somehow we may be missing something in our own solar backyard. It doesn't just seem unlikely, it's unsettling. But recently, new clues have emerged, hidden in data, buried in observations, pointing to where this elusive world might be hiding. To understand where Planet 9 might be hiding, we first need to understand just how vast the solar system really is. Neptune, the most distant known planet, already sits about 30 AU from the Sun. That's 30 times farther than Earth. But Planet 9, it could be more than 500 astronomical units away. That distance is almost impossible to comprehend. Even light, the fastest thing in the universe, would take nearly 3 days just to get there. And with our current technology, the journey becomes staggering. Even some of the fastest spacecraft ever built, like Voyager 1, would take over a century to travel that far. This isn't just distant, it's practically uncharted. Beyond Neptune lies a vast region known as the Kuiper Belt, a frozen halo of icy objects left over from the formation of our solar system. Here we find dwarf planets like Pluto, along with countless smaller worlds made of rock and ice. But even beyond the Kuiper Belt lies something far more distant, a sparse, mysterious region of scattered objects on extreme orbits, stretching hundreds of astronomical units into deep space. These objects are referred to as trans-Neptunian objects, or TNOs for short. The first TNO was discovered by Clyde Tombaugh in 1930. Now these TNOs are where we start to notice something strange. In 2014, astronomers were observing the Kuiper Belt when they saw several of these distant objects, far beyond Pluto, orbiting in a strange pattern. Instead of the typical orbit we'd expect, their paths are clustered, tilted and aligned to orbit in the same specific path and angle. It's as if something massive was quietly pulling them out from far beyond our view, and this was our first hint. These specific clusters were a subset of TNOs called extreme trans-Neptunian objects. Their orbits act like fingerprints, pointing to a hidden gravitational force, a force that could belong to a massive, unseen planet lurking in the dark. In 2016, astronomers Konstantin Batygin and Mike Brown at California Institute of Technologies took this idea and went for it. They ran tests simulating a massive planet extremely far out in orbit. They found this orbit would cause the objects to cluster on opposite side of the Sun to the planet. This would keep the alignment stable for billions of years. Such a large orbital path would mean it would take 10 to 15,000 years to complete just one cycle around the Sun. The planet would be 2 to 3 times bigger than our planet, which would make it a super Earth, or a smaller Neptune. This size and distance would make it also a frozen world. Believe it or not, but it turns out this size of planet is actually the most common one in the universe. This would mean the solar system wouldn't have one, unless there is a Planet 9. Now, the evidence surrounding Planet 9 doesn't just stop there. Out even farther than the clusters in the Kuiper Belt, there lies a few outliers called detached objects. The planet Neptune is really good about ejecting smaller objects away from the inner solar system. The problem here is over a dwarf planet called Sedna. Sedna has an extremely large orbit, making it a detached object. But our question is, how did it even get this far to begin with? Well, if there was another planet, it could gently bump these detached objects farther and farther away. Of the 4 detected detached objects, all their paths would fit the gravity patterns of the alleged Planet 9. Our evidence doesn't end here though either. Since Neptune likes to play defense and throw objects back into the Kuiper Belt, one would think that eventually Neptune would run out of things to throw, but that's where our friend Planet 9 comes in. In the simulations, Planet 9's gravity would grab rocks from the Oort cloud and sort of launch them towards Neptune, but it doesn't stop there either. We actually found some of these objects, and it turns out their orbital path agrees with the simulation. And the chances of this happening without Planet 9 were 5 sigma, which in the science world basically means impossible, or at least a 1 in 3.5 million chance. Now, you might be asking, if we're so sure Planet 9 exists, and we even know its orbit, why don't we just take a picture of it with a telescope? I had the exact same question, and after doing some digging, it turns out we don't know where it is. Turns out, while we do know its orbital path, it does not mean we know where on the path it is. And since it takes over 10,000 years to orbit, we have a lot of ground to cover. And then there's also the problem of brightness. Since planets don't create their own light, they have to rely on the sun to reflect that light back towards us. And since Planet 9 is so far away, it would be extremely dim. Luckily, we might have a solution. A brand new telescope called Rubin is the newest and biggest telescope we have. It's so precise, it could spot a single fairy light on the surface of the moon, and it scans the sky at incredible speeds. It can do in days what would take older telescopes months. Okay, let's say Rubin still can't find Planet 9. Could it possibly be something else? One rumor is that it could be a primordial black hole. It would still have the same mass as our exoplanet, but its event horizon would be incredibly tiny. This would explain why it's so hard to find. This idea is purely speculative though, and honestly, pretty unlikely. Some other groups believe it could just be nothing, and these weird orbits could genuinely just be random. Either way, something is up, and Planet 9 makes the most sense. Now, how would Planet 9 even form in the first place? And even more, how did it end up so far away? The most popular theory is that Planet 9 was in the beginning of forming an ice giant like Neptune or Uranus. Unfortunately, it was ejected from our early solar system and flung into the colder depths of space. This would make Planet 9 the core of an ice giant that got kicked out before it could finish forming. Now it's stuck wandering far from the rest of everything else. The only other theory is that there was a rogue planet that was simply captured by our sun's gravity. Now, no matter what you believe, Constantine and Mike Brown both think the likelihood of Planet 9 is existing at 90%. Now, let's say we find this planet. What would we even call it? Every other planet in our solar system is named after Greek or Roman figures. So, what would Planet 9's name be? Some ideas are Vulcan, Oceanus, or my favorite, Erebus, which is the name of the Greek god of darkness. Right now, the petition is to name it Bowie, after David Bowie, which would also be pretty cool. I personally think that we're gonna find Planet 9, and that it does exist. It's just lurking somewhere out there in the infinite cosmos, waiting for someone to snap a photo. That's all for this video. If you enjoyed, please subscribe to see more videos. My name is Joshua Turek, and this is Space Capital.